The following theorems are just review of properties of parallel and perpendicular lines in regards to their slopes. We saw these in some version at the outside of the unit when we reviewed equations of parallel and perpendicular lines, but we'll state them again here just for completeness sake. We say that parallel lines, that two non-vertical lines are parallel if and only if they have the same slope, meaning parallel means same slope or same slope means they're parallel. Further, lines are perpendicular if and only if their slopes, when you multiply them, multiply to -1. How do you get that? Well, in order to for two numbers to multiply and the answer is -1, they have to be opposite reciprocals. Those numbers always multiply to be -1. So you should be able to use these facts to look at lines either graphed on a plane or from their equations or some points on them to determine if they're parallel or perpendicular or not. So we'll review that real quick here for the remainder of this video here. Let's determine which of these lines are parallel and which are perpendicular. I've got spaces so you can write down what their slopes are, and then we'll determine which ones are which. Let's see, line A is in blue here. Let's see, some points there in A are these two. Slope is rise over run, change in y over change in x. I'm just going to, rather than write down formula, I'm going to talk through what the slopes need to be. What I mean by that is the rise is change in y. So to go from this point to this one, y goes from 4 to -2, which is a change of -6. X changes from -4 to -2, which is less negative, or more negative to less negative is going up. It's going up by 2. So in total, this is like -3 over 1. Play the same game with B here. Here's a point in B, 5, 7, and this point, 7, 1. So let's see, y changes, goes from 7 to 1, so it goes down 6. X changes from 5 up to 7, which goes up 2. Line C is in blue here, or purple, I guess. Y changes from 1 to 4, which is going up 3. X changes from going from -3 to 6. That's a total change of going up by 9. And that reduces to 1/3. Lastly, line D. Let's see, here's a point 0.7, and here's a point 8, -2. Y goes from -7 up to -2, which is going up by 5. And X changes from 0 up to 8, which is up by 8. And 5/8 does not reduce. So in this picture, what lines are parallel? Parallel lines have the same slope. It looks like A is parallel to B. And again, the symbol for parallel is two lines that look parallel. Are there any perpendicular lines? Are there any lines that have opposite reciprocals or whose slopes would multiply to be -1? I think there are. I think -3 over 1 and +1 over 3 are opposite reciprocals, and same with B and C. And that should hopefully make sense because we had a theorem from previous lesson that said if two lines are parallel and one is perpendicular to a line, then the other is perpendicular to that line as well. And we're seeing that here. Okay, a new line. N passes through these two coordinates. M passes through these two. Are they perpendicular? Well, let's find their slopes and answer that. Again, I'm just going to find the changes and write them as a ratio. From one point to the other, y goes from 2 to 5, so that's a change of up 3. X goes from 0 to 6, that's a total of going by up 6. And 3 over 6 reduces to 1/2. How about these two? Y goes from 4 down to 0, that goes down by 4. X goes from 2 up to 4, that goes up 2. This, as a fraction, reduces to -2 over 1. So are they perpendicular? Absolutely. How do you know? Their slopes are opposite reciprocals. Let's see, one more thing here. Line K passes through these 2 points, and we want to graph a line that's perpendicular to this one and that also passes through this specific point. All right, let's start by at least graphing k, and then we'll worry about this perpendicular line stuff. K goes through the point 0, 3, so over 0 up 3. And 5, 2, over 5 up 2. 1, 2, 3, 4, 5, 1, 2. And I'll try to make this straight. I'll grab this straight notebook, or I guess notepad here. And here's line K. I want to graph a line that's perpendicular to this one, and also goes through this point 1, 2. So maybe I'll plot that point over 1 up 2. And I need to somehow draw a line that's perpendicular here. Now, I guess you could use a compass if you wanted. If you remember how to use a compass to construct a line that's perpendicular to another and goes through a given point. But that's not exactly, I don't think, the most efficient way to do this. Maybe if we use what we know about slopes, in that we know that the slopes of two lines that are perpendicular are opposite and reciprocals. So I think if I could figure out the slope of K, I could reciprocal and change the sign, and then I could just draw a line with that slope that starts at this point, and use my straight edge to draw it in from there. So I want to find the slope of K, which again is going to be change in y over change in x. Y goes from 3 down to 2, so that's down by 1 in total. And x goes from 0 and to the right 5, so that's adding 5. So the slope of K is negative 1/5. So I think of a slope that's perpendicular to K should be 5 over 1. And then the K was negative, so our perpendicular line will be positive. So let's finish this. Let's just draw in this line that has a slope of 5 over 1 and starts at this point and goes to this point. So I could go 1, 2, 3, 4, 5, and over 1. I'm off the graph paper. It's not going to be very precise. How about I do, instead of going up 5 into the right one, I could go down 5 into the left one. Because 2 negatives would make positive. So I don't have to go up and right. I could go down and left. 1, 2, 3, 4, 5 into the left one. There we go. That stays right on my piece of paper. And I will use my straight edge here to draw my line that is perpendicular.